Have you ever stopped to think, I mean really think, about how much ancient civilizations actually understood about the cosmos?
Hmm.
We tend to think, advanced astronomy, that's us, modern times, telescopes.
Right, complex calculations, space probes, the whole deal.
But what if, way back, thousands of years ago, people were already, say, calculating eclipses, tracking planets, maybe even building observatories with, well, frankly, stunning precision?
It's a really compelling thought, isn't it? We often picture ancient stargazing as, I don't know, purely mystical, maybe a bit basic.
Yeah.
But when you start digging into the archaeology, the old records, a much, much more sophisticated picture starts taking shape. It's quite something.
And that is exactly what this deep dive is all about today. We want to pull back the curtain on this unexpected astronomical know-how in ancient cultures across different continents, too.
Yeah, it wasn't just one place.
We're going to explore the ingenious ways our ancestors looked up, not just wondering, but for really practical reasons, profound reasons even. Things like keeping time, guiding trade.
Absolutely. And to do that, we've pulled together some really fascinating stuff for you. We're looking at archaeological studies, papers on places like D'Oliveira in the Harappan civilization,
Right.
the famous anti-Cathar mechanism, of course, and then the astronomical links at places like Stonehenge, Machu Picchu, plus ancient records from China.
It sounds like we're in for some real aha moments. Stuff that might just flip your perspective on the ancient world.
I think so. Get ready.
Okay, let's kick things off by heading back to the Bronze Age. We're talking about the Harappan civilization, probably one of the largest, most sophisticated civilizations of its time. We're looking at maybe 2500 to 1900 BC.
That's the time frame, yeah. And vast doesn't quite cover it.
Oh.
Over 1.5 million square kilometers. They were trading across huge distances, thousands of kilometers, connecting with Western Asia, maybe even the Horn of Africa. A truly organized, interconnected society.
Impressive scale. And
Yeah.
within that huge area, there's one city, D'Oliveira, that's giving us some incredible astronomical clues.
That's right, D'Oliveira. It's in modern-day Gujarat, India. It was a major trading port back when it was on an island in the Rann of Kutch.
So a big trading hub like that, they'd need accurate timekeeping, right?
Yeah.
Trade for agriculture, maybe religious events.
Absolutely critical. And it looks like they achieved that not just by watching the sky, but by actually building it into their structures, specifically this area called the Bailey.
The Bailey. Okay, tell me about that.
It's just west of the main citadel in D'Oliveira, and there's this rectangular building, 13 rooms, but inside it, 2 circular rooms. Very unusual.
Circular. Why is that unusual?
Because Harappan architecture is famously rectangle-loving, is how researchers put it. Straight lines, right angles. So these circles, they jump out, they strongly suggest specialized purpose, something different from just living quarters.
Okay, so not your standard Harappan house. What's special about these circular rooms?
Well, several things point towards astronomy. First off, the ground in the Bailey area itself. It slopes upwards towards the north at an angle of almost exactly 23.5 degrees.
23.5 degrees. Wait, isn't that related to the Earth's tilt?
Precisely. And more importantly, it exactly matches D'Oliveira's latitude.
Whoa. Okay, that can't be a coincidence. What does that mean practically?
It means if you stood at the southern end, that specific slope would let you easily observe all the circumpolar stars, the ones that never set below the horizon from that location. The land itself was like a giant, perfectly angled viewing platform.
That's incredibly clever engineering, built right into the landscape.
It is. And there's more. The city itself is aligned about 6 degrees off true north, but these 2 circular rooms, they had openings facing exactly due north and due west. Dead on.
Okay, more precision. And you said they weren't living spaces.
Doesn't look like it. Too small, no amenities like bathing areas, and unlike other rooms, just one single entrance each. Plus, they had these stone walkways leading up to them, which is also pretty unusual for Harappan buildings.
And I read something about pits nearby, too.
Yeah, at the southern end of the Bailey, 2 deep rectangular pits. No stairs to get down into them. The thinking is they might have been used for observing stars directly overhead at the zenith, another fixed reference point.
So all these odd features, circular rooms, the slope, the precise openings, the pits. How do researchers think they actually use these as an observatory?
Right, so they ran simulations. They assumed a reasonable wall height, say 2.5 meters, flat roofs, and maybe half-meter circular holes in the roof apertures. This fits with what we know about Harappan building.
Okay, so picture a room with a hole in the roof.
Exactly. Now, for the northern room, the simulation showed that at local solar noon, right when the sun is highest, on the summer solstice, the longest day, that circle of sunlight coming through the hole would fall precisely on the very southern edge of the walkway inside.
Okay, a specific spot on a specific day. What about the winter solstice?
On the winter solstice, the shortest day, that same circle of sunlight at noon, its northern edge would just graze the bottom edge of the circular wall itself.
Wow. So the light's position tells you the exact day.
It suggests that, yeah, if you had maybe a marked plank on that walkway, you could use the position of the sunlight patch to know exactly where you were in the year. A solar calendar, essentially, built into the room.
That's ingenious, using sunlight like a clock hand on a yearly dial.
What about the other circular room, the western one?
Similar principle. For the western room, the noon sunlight on the summer solstice would graze the southern wall. On the winter solstice, its northern edge would pass close to the bottom of the straight wall section.
Okay.
And there's more. Just outside this western room, there were two walls running east-west. Their shadows, at sunset on the summer and winter solstices, would precisely touch the entrance of the room. More markers.
Sunset markers, too. So, taking this all together, what does this discovery really mean for how we understand the Harappans?
Well, it's huge. This looks like the first identified Harappan building specifically built for solar observation. It shows they had advanced knowledge of positional astronomy, and crucially, they were applying it for timekeeping, which, as you said, would be vital for a big trading city like Dolavira.
Absolutely. Coordinating trade, knowing when to plant, maybe scheduling festivals. It implies this level of astronomical sophistication probably wasn't unique to Dolavira. You'd expect similar structures in other major Harappan cities. It really forces us to upgrade our assessment of their scientific and technological capabilities back in the Bronze Age.
It really does. Okay, from Harappan architecture, let's jump forward in time and shift focus to a single object, but one that's maybe even more mind-blowing. A piece of technology so advanced, people literally didn't believe it could be ancient. Let's talk about the Antikythera mechanism.
Ah, yes, the Antikythera mechanism. Found back in 1901, just this lump of corroded bronze and wood pulled from an ancient shipwreck off a Greek island.
This looked like junk at first,
For
right?
2 years, yeah. Then someone noticed a gear wheel inside the corrosion, and suddenly this lump transforms into possibly the most sophisticated piece of technology we have from the ancient world. The oldest known example of an analog computer.
An analog computer. From ancient Greece. That's the bit that gets me. Scholars initially called it prochronistic, right? That it shouldn't exist that early.
Exactly. It seemed too complex, too advanced for its time, probably around the 2nd or 1st century BC. Its capabilities were just astonishing.
So what could it actually do, this hand-powered device?
Okay, get this. It could predict astronomical positions, sun, moon, maybe planets and eclipses, decades into the future.
Decades, wow.
And not just celestial stuff. It tracked the 4-year cycle of the major Panhellenic games like the Ancient Olympics, the Isthmian Games, Pythian, Nemean.
So it was an astronomical calculator and a sports calendar.
Pretty much. It did all this with an intricate system of at least 37 meshing bronze gears. These followed the movements of the moon and the sun through the zodiac.
And it wasn't just simple circular motion, was it? Didn't it model the moon's weird orbit?
It did. It modeled the moon's irregular elliptical orbit, how it speeds up when it's closer to Earth and slows down when it's farther away. This is based on theories developed by astronomers like Hipparchus back in the 2nd century BC.
Incredible mechanical simulation of quite complex astronomical theory. What about the dials? How did it display all this information?
Super complex dials. On the front, you had the zodiac, the sun's path, and a movable ring for the calendar, originally thought to be the 365-day Egyptian solar calendar, but newer research strongly points to it being a 354-day lunar calendar instead.
A lunar calendar. Interesting. What about the back?
Even more complex. The back had these amazing spiral dials. The main one tracked the Metonic cycle, 235 lunar months, about 19 years when the moon phases repeat on the same calendar dates. Then there was the Saros spiral, 223 months for predicting eclipses. It even had little symbols, glyphs, indicating if it was a solar or lunar eclipse, the day, even the hour.
The hour of an eclipse.
Yeah. And smaller dials tracked the game cycle we mentioned, another called the Callipic cycle, a refinement of the Metonic. And the Exeligmos dial, that's a triple Saros cycle, used to get even more precise eclipse timings, adjusting for that awkward extra third of a day in the Saros cycle by indicating if you needed to add 8 or 16 hours.
The level of detail is just staggering. And I heard the box that came in was basically the instruction manual.
That's right. The wooden casing had inscriptions explaining how it worked, detailing the lengths of these cycles: 76 years for Calippic, 223 months for Saros, 235 for Metonic.
So how did they make all these intricate calculations happen mechanically? You said it had a hand crank?
Yep, a single hand crank. You turn that, it moves a main date pointer, and simultaneously, through all those gears, it calculates and displays everything else. The moon mechanism was particularly clever, used epicyclic gearing, gears riding on other gears, and this unique pin and slot mechanism.
What did the pin and slot do?
That was the key to modeling the moon's variable speed. It mimicked the effect of Kepler's second law, equal areas and equal times, even though the Greeks didn't know the orbit was elliptical. It also accounted for the slow precession of the moon's orbit over about 8.88 years.
Mind-blowing. And the moon phases?
A differential gear. One of the earliest known examples calculated the difference between the sun's and moon's positions to show the phase, displayed by a little ball, half painted white, half black, that rotated.
So clever. Have we learned anything new about it recently? With modern tech?
Absolutely. CT scans, really high-resolution imaging done in 2016 and more in 2021, have revealed hidden inscriptions and details about the gearing. They found numbers linked to the synodic cycles of Venus and Saturn: 462 years for Venus, 442 for Saturn, to repeat their pattern against the stars.
What does that tell us?
It suggests the mechanism might have been designed to model planetary movements more accurately than we first thought. Maybe by cleverly sharing gears between different calculations. It keeps getting more complex the more we look.
Okay, it's clearly an engineering marvel. But
Yeah.
how accurate was it, really, given the astronomy they knew back then?
That's the million-dollar question. Theoretically, based on the Greek astronomical models available before Ptolemy really refined things, and long before Kepler's laws, there were built-in inaccuracies. Simulations show, for instance, the pointer for Mars could be off by, well, up to 38 degrees sometimes.
38 degrees, that's quite a lot.
It is. It wasn't a flaw in the gears, necessarily, but in the underlying astronomical theory it was built to represent.
Okay, so theoretical limits. What about mechanical limits? Could they actually build it accurately enough?
That's the other factor. These were hand-built gears, probably with simpler triangular teeth, not the precision-shaped teeth we use now. Friction would have been a big issue. One study noted the friction and inaccuracies in the hand-cut gears probably would have swamped the finer solar and lunar correction mechanisms.
Meaning that tiny adjustments it was designed to make might have just gotten lost in the mechanical noise.
Exactly. And there was even a very recent simulation, I think aiming for 2025, that suggested because of this specific tooth shape, the whole thing might have actually jammed up after just 4 months of operation.
Oh, wow. So brilliant concept. Maybe not perfectly executed, or perhaps more fragile than we imagine?
Potentially. Or maybe the surviving fragments aren't perfectly representative, we don't know for sure, but it does raise a fascinating question.
Which is?
If it was this complex, could it really have been the first of its kind? Just appeared out of nowhere?
Good point. Seems unlikely.
Almost certainly not. The level of design sophistication screams undiscovered predecessors. This kind of expertise had to be built up over generations. We probably don't find more because bronze was just too valuable, it got melted down and reused.
Any evidence for others?
We have written accounts. Cicero, writing in the 1st century BC, described 2 similar machines built way back by Archimedes in the 3rd century BC that showed planetary movements, and another built by Posidonius around the same time as the Antikythera device. So, the technology existed, it was known. The mechanism we found is likely just a rare survivor.
Fascinating. So it wasn't an anomaly, just exceptionally lucky preservation. This really paints a picture of widespread ancient ingenuity. But it wasn't just individual devices, right? Whole cultures built their understanding of the cosmos into massive structures.
Absolutely. The Antikythera is amazing, but let's zoom out again and look globally. You can't talk ancient astronomy without mentioning Stonehenge.
Of course. The classic example, famous for its alignment with the solstices, right? Summer sunrise, winter sunset.
That's the one, and people noticed this early. William Stukeley was writing about the midsummer sunrise alignment back in 1720. The whole field of archaeoastronomy arguably kicked off debates right there.
Yeah, I remember reading about Gerald Hawkins's Stonehenge Decoded, suggesting it was like a Neolithic computer for predicting eclipses, and Alexander Thom's work on megalithic yards. Lots of debate.
Huge debate, and it continues. But recent work often emphasizes the winter solstice. Finds from Durrington Walls nearby, that big settlement complex, lots of pig bones, suggesting massive feasts happened in winter.
Winter feasts. So maybe the winter solstice sunset was the main event.
That's a strong theory. Some archaeologists have even argued quite strongly that the primary use was in winter, though, like all things Stonehenge, evidence gets reevaluated constantly. The focus seems definitely solstice related, though.
Okay, Stonehenge is iconic, but you mentioned Nabta Playa earlier, potentially even older.
Much older. Nabta Playa in the Egyptian Sahara. It's basically a stone circle dated to around 7,000 years old. That makes it about 2,000 years older than the main phases of Stonehenge.
Wow. And what was its purpose?
Seems it was built to track the summer solstice. And maybe just as importantly, to predict the arrival of the summer monsoon, rains absolutely vital for survival in what was then a wetter Sahara.
A practical calendar marker. Is it definitively the first astronomical site?
Well, that's debated. Some point to even older sites like Göbekli Tepe in Turkey or Wurdiuong in Australia, maybe even cave paintings in France from 40,000 years ago that might have astronomical meaning. It's hard to say for sure. And sadly, Nabta Playa has suffered from vandalism and parts were even relocated, so some context is
A
lost.
shame. Okay, let's leap across the Atlantic now to the Andes. Machu Picchu. The Inca.
Right, and for the Inca, the sky wasn't just something to observe, it was deeply integrated into everything. Their calendar was intricately tied to natural cycles, particularly the movements of the sun,
How did they build this connection?
through incredibly precise architecture. Think of the Intihuatana stone, the hitching post of the sun, or the sun gate, Intipunku. These aren't just random structures, they are precisely aligned to mark the solstices and equinoxes.
And this wasn't just for show, right? It had practical uses.
Absolutely fundamental uses. This knowledge guided their entire agricultural cycle, when to plant maize, potatoes, quinoa, when to harvest. It dictated the timing for major religious ceremonies, like Inti Raymi, the festival celebrating the sun's rebirth at the winter solstice.
So it was agriculture, religion, timekeeping, all woven together through astronomy.
Exactly. A really clear example of a civilization living in what you might call a symbiotic relationship with the heavens, real harmony.
Okay, one more stop on our global tour. Ancient China. They seem to have been meticulous observers.
Meticulous is an understatement. They have by far the most extensive and accurate records of comets from ancient and medieval times. These go back reliably to at least 613 BC, maybe even earlier.
Wow, what kind of details did they record?
Incredible details. They actually distinguish between different types of comets: bushy stars if they didn't see a tail, boom stars if they did.
Huh. Bushy stars and broom stars.
And here's something really impressive. By at least 66 and 35 AD, Chinese astronomers had noted that comet tails point away from the sun.
Centuries before that was understood in the West, that's a major physical observation.
It really is. It shows incredibly careful long-term observation and analysis.
How do these ancient Chinese records help us today?
They are pure gold for modern astronomers. Because they're so extensive and accurate, we can use them to reconstruct the past orbits of comets and see how their paths might have changed over centuries due to gravitational nudges from planets.
Like with Halley's Comet.
Exactly. The Chinese records were key to calculating Halley's orbit back way further than European records allowed, back to 1404 BC. They filled in gaps caused by things like a close pass to Earth in 837 AD that made Western calculations difficult before that point.
So ancient observations directly enabling modern science. Amazing. Why were they so dedicated to recording comets?
Well, alongside the scientific curiosity, there was astrology. Comets were almost always seen as disastrous omens.
So the emperor wanted to know if disaster was coming.
Precisely. Emperors employed official observers specifically to watch for comets and other omens. Bad news for the emperor, maybe, but great news for the preservation of astronomical data.
Okay, let's just take a breath and try to pull this all together. We've gone from Harappan observatories built into the landscape to this incredible Greek analog computer to solstice alignments in Britain and Egypt, sun-synced life in Peru, and detailed comet logs from China.
Yeah, it's quite a journey.
It really shows that ancient people weren't just idly stargazing. They were serious astronomers, serious engineers, using the cosmos for fundamentally important things. They were charting, calculating, building, connecting with the universe's rhythms in profound ways.
And critically, these aren't just, weird one-offs. It's a global pattern. Different cultures, different continents, same drive to understand and utilize the sky. It forces us to completely rethink the timeline of human ingenuity, doesn't it? Scientific thinking, complex engineering, it was happening much, much earlier than the old, simpler narrative suggested.
It really does. It paints a picture of ancient civilizations being far more dynamic and innovative. So the big question then is, what does this mean for us looking back now? What else might be out there?
Exactly. What other lost technologies or forgotten knowledge are still buried, waiting to challenge our assumptions even further?
It makes you wonder. This deep dive feels like just scratching the surface of humanity's long, continuous journey of discovery, reaching for the stars in ways we're maybe only just starting to fully grasp.
Perhaps there are messages still encoded in those ancient stones, those corroded gears, just waiting for us to finally look up and figure them out.